Right, should we get started? Okay.
Let's do it.
Hi, everybody. Thanks for coming. This is the OpenStack Charms project update, so hopefully you're all in the right room. My name is James Page. I'm the current PTL of the OpenStack Charms project, and
I'm Ryan Beisner, and I'm one of the OpenStack Charmers and engineering manager at Canonical.
Okay, so I thought we'd better do a quick 101 on what the OpenStack Charms project is. Basically, it's a cost-effective deployment and operations tool for OpenStack at any scale. Project's history dates right back to about 2010, when we wrote the first charms, as the tooling was originally introduced to support deployment, and we'll step through some of that in a little bit to see what the supporting technologies are. Looking at the current latest survey stats, about 70% of deployments are using the charms for deployment, which is encouraging. We're not the top, but not the bottom either, so it's generally an okay story. Okay, so which projects do we cover? We don't cover every OpenStack project. We generally cover most of the core infrastructure as a service projects, and a few peripheral services like Gnocchi and AODH for telemetry, alarming and storage of metrics and measures from across your cloud. We have some incubating charms for Trove, Mistral, and Panko, but those aren't mature or released as part of the charm set at this point in time. So if anybody would like to contribute on those, they're more than welcome to. And we'll talk about how people can contribute towards the end of the talk. Okay, so in order to understand what the OpenStack charms are from a technology perspective, it's quite important to understand the supporting technologies around charms, and then you'll understand it in the context of the full suite of technologies we use. So the first tool we need to talk about is Juju. So Juju is an application modeling tool. It really works around the semantics of applications, the machines you deploy those applications to, the networking associated with those machines and applications, and any storage requirements they may have at the same time. And how that then gets deployed either onto a cloud substrate for maybe some application workloads, or in the case of OpenStack, how that's deployed onto hardware. And how that's done for OpenStack on hardware is using a tool called MAS, or Metal as a Service. And basically that's a bare metal provisioning and data center automation tool. Provides a scale-out infrastructure for managing large data centers. So it's a kind of rack region controller architecture with central control in the region controller and rack or network locality control in each rack controller component. And it basically provisions machines, and that's all it does, and it does it really well. For the context of the OpenStack charms, that's Ubuntu is important, but it also supports RHEL, CentOS, and Windows, just as interesting facts along the way. So what are charms? Charms are the kind of distribution format for Juju. So it's how we wrap up the knowledge of how to deploy, install, configure, scale up, scale down, upgrade, how one part of OpenStack relates to another in the context of the OpenStack charm. So it's a kind of encapsulation of all that knowledge into a packet that we then give to Juju to deploy. So for example, we have a Neutron API charm that encapsulates how to install the Neutron server daemon from packages, how to configure it, how when that's related via a relation to, say, Nova or Nova Compute nodes, what information needs to be passed to allow the other components within the OpenStack deployment to be configured and brought up correctly so you get an operational cloud. The OpenStack charms build on top of those base principles to include things like how you deploy services in HA configurations and how you upgrade between OpenStack releases. So how do I take my cloud from Mitaka to Newton to Okata to Pike to Queens to Rocky? That's encapsulated as code within each of the charms, so each service can be upgraded over time as part of the life cycle of a cloud. So charms aren't just about deployment, they're also about the ongoing operations and management of your cloud over time. So whether that be a series upgrade or a scale out of your hypervisors, that's all dealt with by the charm code base. The last technology I wanted to talk to, which is the logo on the right up there, is LexD. So LXD is a machine container daemon. It provides what we call full system containers. So these are containers, Linux kernel-based containers that have everything from init onwards. So there's no dedicated kernel. They share kernel with the host, but it gives you a full machine encapsulated within a container. And we use that to encapsulate each of the personalities within the control plane of an OpenStack cloud. So as we're deploying the cloud to hardware, we can push the various components of the control plane into containers in highly available configuration across the physical servers that are supporting the cloud, which allows us to make the most use of the hardware that's being used for the cloud for either storage or compute or both of those personalities. Okay, so quick one-on-one. If anyone's got a question, please ask at the end. We're just going to talk about some of the work we've done this past cycle and what we've got planned for Queens. So Ryan's going to walk us through some of this, and I'll chip in as required.
So along the end of August, we released, or the first week of September, we released the latest stable cut of the OpenStack Charms to include Pike support. This delivered a couple of new features, or rather new charms, one of them being on the Gnocchi charm, time series database for telemetry. Load balancer as a service, V2, we got some polish put on that and delivered that through the OpenStack dashboard completion. Number of things happen with the release process here, but I guess we'll talk about that in a bit with the contribution.
Yeah.
I'll let you talk about the LXD stuff.
Yeah, so the LXD deployment optimization, this is kind of a bit of an asked for feature we've had over the last 12 months. So when you spin up a LXD container on a physical host, by default, and this is the way Juju provisions it, it can see all the memory and processor resources of the host it's residing on. Now, if that container happens to end up on a hypervisor machine, that's potentially, 64 cores, half a terabyte of RAM, and we need to auto-configure services as much as possible based on sane defaults. Now, running your Neutron server with a worker process for every core on that box is not sensible in this type of deployment. So unless you instruct the charms to do otherwise, this optimization piece basically puts some sane caps when you're deploying services in LXD containers. So, for example, for most API services, we cap automatically at 4 worker processes. You can override that with configuration. So you can say, actually, no, I do want like 16 cores of workers, or I want a 50% multiplier on the number of cores of the box. There's kind of a number of semantics there. But what we wanted to do was make sure that people didn't trip themselves up by using defaults. So by capping at 4 cores, that gives people function, and then they can tune up and down from that as they need to. The other thing we brought in alongside the OpenStack Pike support was support for Ceph Luminous, which is the latest stable release from the Ceph project. So the OpenStack Charm project covers the OpenStack services, but it also covers deployment of a number of supporting services as well, Ceph being one of them. Other services would include RabbitMQ. We have charms for Picona XtraDB cluster, which is a scaled-out MySQL alternative. And other supporting technologies like the HA stack, pacemaker, chorusing, stuff like that is all part of that charm set. One thing that's worth mentioning about our release cycle is that we do try and line up as much as possible with the main OpenStack release cycle. So during the OpenStack development cycle, we will also be delivering the charm features to support the new OpenStack release. So with the aim of being that on the day of OpenStack release, you can deploy that release using the OpenStack charms on the latest Ubuntu LTS release, which at the moment is 16.04.
I think kind of an important designation there is that each of the charm releases support all of the currently supported versions of OpenStack in terms of what Ubuntu supports.
Yeah, the charms support those multiple series so that existing deployments don't get automatically upgraded, so that the version of the charm doesn't tie directly to the version of OpenStack. They're orthogonal to each other.
That's really necessary so that you can have the same charm code base allow you to upgrade, as you said earlier, from Icehouse all the way forward, essentially.
Okay, so what have we got planned for Queens?
Well then, Ubuntu series upgrades is one of the big things, I think. This means going from LTS to LTS. If you're familiar with the Ubuntu Cloud Archive and how we distribute, or how OpenStack is distributed on Ubuntu, essentially the Cloud Archive pockets are available at the latest LTS. So for Trusty, that was Icehouse all the way through Mitaka. But in order to get from Mitaka to Newton, Okata, Pike, and Queens, and later, you will have had to have gone to Xennial to do that. And so there was a previous limitation in the Juju tooling that's overcome now. And so in this coming cycle, we'll deliver support for that Ubuntu series upgrade, which will allow for example, a Trusty Liberty Cloud to be upgraded to Trusty Mitaka, and then Xennial Mitaka, and then Xennial Okata on up to current, right? So that's a pretty big piece of work. Next thing we've got coming is kind of revisiting, as I'm sure other folks have followed the lineage of cells in Nova. It feels like it's ready to rock, so we're going to start implementing that support. I think we'll go Okata, or rather Pike Queens on the cells, if I'm not mistaken.
Yeah, so I think Queens will probably be the minimum OpenStack series support we have for that. But, so we'll probably mark it experimental for Pike users and move to Queens if you really want to use it in production.
Indeed. Next thing is runtime Python 3 only for the charm code. So we want to be ahead of the curve when the requirement hits as a hard requirement. So this is something that we'll actually bring in ahead of that. Also, we're going to be using Keystone v3 as default for all the series that support it. And James, I'll let you talk about network spaces and the ACLs in Swift.
So I alluded to this feature earlier when I talked about Juju in terms of it understanding the network resources that an application needs to consume. So as of Juju 2.0, which was released last year, Juju has top-level support for understanding the network topology within your data center. And it does that in conjunction with MAS, that does a lot of the discovery of the underlying network fabric. And then that's mapped into what's called network spaces in Juju. So a network space is a collection of subnets within your data center that are equivalent from a security and routing perspective. So this allows you to deploy an application and bind aspects of the services that application provides, whether that be an API endpoint or access to a database, to a particular set of networks within your data center. So you may have public networks for inbound access to API services, but you may want to segregate out your internal admin traffic from API services to database and messaging onto a private backend network. You may need to have high capacity networking for storage services like Ceph and Swift. Again, you may want to have high capacity networks for tenant data networking, for overlay network transports, that sort of stuff. And the charms as a whole have supported that relatively well since that feature was available in Juju 2.0. So you can use that for a majority of network configuration touchpoints across an OpenStack cloud. The one place that's not been great has been in the Swift charms. So we're introducing full network support across the Swift charm. So that's the ability to have your public-facing proxy, which is the front-end component of Swift, bound to your public internet-facing networks, and to be able to segregate out the storage traffic onto back-end networks. And then a wrap on top of that is putting ACLs on the Swift storage ports, which by design don't have any type of authentication on them. So those things can only be accessed from the proxy servers themselves over the back-end network space binding. So this really ties down the security around a Swift deployment in a much better way than we have today. So clustered deployment optimization. I talked about the fact we can deploy OpenStack services in HA configurations. The charms kind of, when you deploy them, can evolve over time. So you can start non-HA, you can start with single units of API endpoints to try things out, see how they work. And then the idea is you can evolve your deployment over time to add more units, make them fully HA so they're accessed via virtual IPs, that sort of stuff. But it means that the charms have to kind of understand all the interim states that you go from single unit to I'm being clustered to I'm now clustered, I need to update my Keystone endpoints, that sort of stuff. So for clouds that are being built where that's the ultimate end game in the short term because you're deploying 3 units and they're going to be clustered because that's what's in your bundle for your deployment. We can put in various optimizations to ensure that things like endpoints aren't registered until services come up and have been fully clustered, and that credentials aren't given out until databases are fully formed or RabbitMQ clusters are fully created. And it means there's a lot of hook executions, which are the kind of primary interaction point between services when data changes, can be avoided so that the total time it takes to deploy an HA cloud can be greatly reduced. Because basically, a lot of the kind of interim states are completely deferred, and the cloud will just come up HA and won't provide services until things have reached the right scale and have been fully configured to be highly available. It's not long anyway, to be honest, but it's an important, when you get used to building clouds in a couple of hours in HA configurations, it starts to feel slow after a while. So getting that down is a good challenge for the team, and hopefully we'll meet that challenge. Certificate management. We've had certificate management for a long time, but it kind of predates a lot of the network space support in terms of being able to support multiple networks and binding different endpoints onto different networks. So we need to evolve that to support multiple network bindings and various other options that users have asked us for in terms of how they want to provide certificates, how they want to ensure that the signing authority may be a private one or a public one. There's a whole heap of configuration options that we really need to support to make that effective in deployments. And we've got some work on finishing off our Ceph Blue Store support. So Blue Store is the new underlying block device format in Ceph Luminous. There is initial support for it under Luminous in the Charms as of the last release we did in August, September. We're mucking that experimental at the moment because we haven't exposed all the various kind of knobs and tuning bits that we normally do in the Charms for Blue Store at the moment. So things like being able to split out the metadata and the write-ahead log for a Blue Store block device onto different block devices is not there yet. And we need to get that feature up to equivalency with the file store support we have today before we'll make a default switch, which we'd like to do, but we want to put that through the mill first before we make that switch. And the other one, which has been contributed from outside the core team, which is quite nice, is an integration between Designate and Neutron. We've had Designate, the DNS as a service in the Charm set for a while. That's been driven by the original notifications approach using messaging to populate DNS records. Neutron's had a DNS extension driver for a while, so we're going to enable the integration between Neutron and Designate. So Neutron will directly drive Designate for creation of DNS records for tenant instances.
Couple minutes left.
Okay. Future stuff, so beyond Queens, we've got some work that we might do on refactoring our load balancer architecture, support for OVN, which is part of the Open vSwitch project, and Panko for telemetry events. And I'm sure there'll be other things, but that's the current shortlist. Okay, so how can you get involved? We have weekly meetings on IRC. They alternate between 10 o'clock in the morning UTC and 5 p.m. in the evening UTC to try and get as much time zone coverage as we can. If you're not in that, please say, and then we might reschedule one of them. The 10 o'clock one is not particularly well attended, so there's an opportunity to move that forward or backwards a bit if that would be more convenient. We work off OpenStack and the OpenStack dev mailing list. So if you use the Charm subject header, if you have a question, that gets it in front of the core, the development team around Charms. You can join OpenStack Charms on Freenode IRC. Most of the team hang out there. If you ask a question, don't get an answer instantly, don't worry. It probably means that right person isn't awake yet. And you can take a look at our current documentation. The Charm guide's really quite developer-centric, talks about coding standards, policies, release cycles, all that sort of good stuff. And the deployment guide is more end-user focused. If you want to try the Charms with Maz and Juju, it's a bit of a nut to bolts guide on how to get started with all those tools and then how to use the Charms to deploy OpenStack on top of that. Okay, so how can you contribute? Kind of standard list of things. Our documentation is getting better, but if you're a Charm user, please contribute and tell us where you're doing things differently or what works for you, what doesn't. Help on IRC is always good for users who are asking questions, kind of normal bug fix, documentation, and features cycle. So I think that kind of brings us to the end. How many are we on time? No, we're pretty much done.
Yep.
So if anybody's got any questions, probably got 30 seconds now, or we'll be in the hallway afterwards. OK, thank you.
Yeah, thanks for coming.